Okay, hello everyone. Hopefully you can hear me okay. Ravi, thank you very much. And a few of you are typing as well, so that's good. If one or two of you can hear me, that's probably good news. Right. Right now, I'm just going to move the little chat pod out of the way. It'll disappear from your screens in a moment too, so apologies if you're typing in there at the moment, but we'll get this out of the way. I'll pull it back in again at the end, and we can have a bit of a catch up. But there we go, that's gone. Right, so welcome to this afternoon's session, a Telecoms Academy Insight webinar. And the topic of discussion today really is 5G technologies and business. Some of you may have attended the session we did I think a few weeks ago now, I think, on VoLTE. And I think one of the things that we were asking was, what technologies and so on, what subjects we'd be interested in the field of communications. And I think 5G was one of those things that came out on top. So, well, here we are doing something on 5G. Right, now we are recording this session. Paul Waite, our marketing guy, he will make that available to everyone who's signed up for this later on. Yeah, thanks for just filling in a few of those little boxes at the bottom there. It's always interesting to find out what people are thinking about 5G. In fact, if and I suppose because you're here, you are thinking about 5G, which is pretty good. 5G seems like quite a long way off. I mean, we're talking about 2020 seems to be sort of the date at which you might have these things, and 5 years is the gap that we got from now till then. But I guess in terms of telecom, that's 5 years is quite a long time. But in the sort of research I've been doing for this and putting together some materials, there's a lot of work to do in the 5 years. And if we hit those 2020 timescales, I think everybody in the industry is doing a fantastic job. So it's interesting to see some of the services that you're thinking of there. So we've got real-time remote control, connected car, sort of HD, virtual or augmented reality, and so on. So you can pretty much put whatever you want there. So what services do you think will be possible? Well, pretty much anything. It's difficult to imagine, really, given the capability that we'll probably see from a 5G network. It's difficult to kind of imagine today, what services we'll be using in sort of 5 years' time. So you could put some sort of crazy, sort of Star Trek type services in there, and we wouldn't necessarily rule them out. And I think the other question we asked here, what are the most important attributes of a 5G system? Some good answers in there as well. I mean, capacity clearly is one of the things that we have to be concerned with, given the current trends, current demand, and so on for data and data-like services, and the number and different types of devices that we have connected to the system at the moment. So yeah, capacity clearly has to be a thing. Connection anywhere, possibility to switch between different access technologies, and so on. And another important thing, I think, because we've got to be able to distribute the capacity, I think, between a lot of different types of technology, flexibility, scalability, data capability, adapt the network core and access to the type of service. I think that's an important one as well. And in fact, pretty much everything that you've written down here, we're going to see some aspects of that, I think, as we kind of begin to look at what the big standards bodies and organizations are recommending for what 5G should really look like. So hopefully those of you that have commented will see reflected in the presentation some of the ideas that you're coming up with here. So as I said, there's a lot of work to do on 5G, and hopefully we can sort of demonstrate that throughout the course of the next sort of 30 or 40 minutes or so. Now let's get cracking with this. So we are the Telecoms Academy. Some of you may have attended our training courses or attended these online sessions before, but we're part of Informa Telecoms and Media. Telecoms Academy is, should we say, is the training arm of Informa Telecoms and Media. So, what we do this. We do training. We do training in technical subjects. So of course we do a lot of stuff on LTE, voice over LTE, some basic telecom stuff as well for those just getting into the subject. And we do a lot of classroom-based training, both as we might call them in-house. So we'll visit companies directly, and we can do customized programs and so on directly in-house for particular companies, operators, vendors, and so on. But we also offer pretty much anything we do in the portfolio as part of a distance learning or a correspondence program. And as well as the technical subjects, we've also got what we're referring to here as the School of Telecoms Management. So there's a lot of still telecoms related, but perhaps less on the technical side and more on the management and the business side. So, one of our most popular programs really is this Telecoms Mini MBA here, where we can basically teach you everything about being a mobile operator and I guess the commercial, marketing, and technical requirements of operating a network, and we can do all of that in inside of 5 days. It's a sort of intensive 5-day program. So of course, we cover a lot of ground with the training that we do. So what I recommend you do, rather than me explaining it all, is go and visit our website, download one of the brochures. If you've got any training inquiries, the numbers, the emails, addresses are there, and I'll show you this slide again right at the end, so you can make a note of those if you're interested in following up with some of the training programs that we do. Now another it's very valuable for a person like me who's working for the Telecoms Academy and doing a lot of different kinds of training, but we find it extremely useful now in this partnership we have with Ovum Research, and in particular this knowledge center, this online resource that we have. So whenever we get asked questions about trends in telecoms or financial metrics and so on, we can just visit this webpage and pull out all kinds of really up-to-date information about the world of telecoms. So so Ovum now really sort of replacing Informa Telecoms and Media as the research arm of the company. But we work very closely with those guys, and a lot of the data that we would normally put into presentations and into the training that we do, is coming directly from the Ovum people. So, we'll get on with today's content, and obviously the 5th generation stuff is what we're here to talk about. So 5G, what we'll more or less cover in the next sort of half hour or so is 5G capabilities and expectations. We'll have a look and see which standard bodies are involved in this process and show you 1 or 2 different timelines and so on. And then we'll talk about applications for 5G. I think an important thing as well is these, the business models for 5G, because clearly there's going to be a lot of different players involved in 5G. So depending on where you are in that value chain, whether you're seen as an operator or a third party or a provider of some other service to the telecoms industry, then the business model, of course, is really an important aspect of this. And then we can focus a little bit more on the technology side. So we'll talk a bit about what the core network might look like and run through a quick list of what we think access technologies might be as well for that. One thing that's apparent and I think really important for 5G to be a success is availability of spectrum. Okay, because it's been mentioned in the little surveys below here. Capacity, and in a radio-based system, there is no capacity without spectrum. And it turns out that various surveys done by ITU and so on that we need an absolute ton of new spectrum for the 5G system to be able to contain all of the capacity that we're predicting. So that's more or less what we're going to do, and we'll move straight on. Now, I've in putting this presentation together, I've used 3 or 4 principal references in here. I've clearly looked at what the ITU are doing, because a lot of the work that they do. We could say that the ITU is more or less responsible for what we think 3G is, what we think 4G is, and of course now what we think 5G is. So it seems like a sensible place to go to find out what the ITU are thinking in terms of what are the requirements of a next generation system, another next generation system. So they have this. They have a document which I would sort of recommend that you go and find and read. Here it is. I'm circling it at the bottom. But this is a document M2290, technology trends. Okay, so it's not a very technical document, but the things that they highlight really is that, should we say that the average throughput of the system has to be dramatically increased. I mean, that of course is based on current trends, and you can see at the bottom of the page here there's some sort of extrapolation here of by how much do we think the capacity of systems will have to increase compared to 2010. In fact, there's a little note there, 2010. This paper actually I think was completed in 2011. So I suspect if we looked at those trends today, it might be a little bit, perhaps a little bit more than that. But they've got quite a wide range here. So somewhere in this so-called estimated growth ranges is what they think. So we're looking at, 20 to 100 times increase in the data capability that we have in the current networks. I mean, that places this benchmark for capacity very, very high. So clearly, both the core and the access network are going to have to be designed with that type of capacity in mind. A lot of focus as well on user experience. Whatever we think user experience might be, and maybe we can sort of categorize that later on. But the user experience, whatever application you're using, should be maintained regardless of the user's location and, of course, the network load. Which is quite a tricky thing to do when you think of the number of different types of services, applications, users, and devices that will be connected to these networks. It's quite a challenge to maintain a given user experience. regardless of its location or in fact the network load. Scalability as well, because well, if you just take these top two bullets here, they kind of end up down here. So lots of users, lots of devices, huge increase in the amount of data. Then clearly any network that we build, any technology that we're going to adopt here has to be extremely scalable. So, and it's no exaggeration to say tens of billions of devices, by 2020, by 2030, and of course beyond that. Any networks that we build and deploying in the year 2020, of course, will have to be on the ground for 5 to 10 years. So in that 5 or 10 years beyond 2020, the scalability part of it really begins to it starts to become very, very important, because we'll be supporting a lot of other industries in this. It's 5G, I think, is it's less about smartphones. It's less about just delivering services to individual users. Or clearly that's part of what the network will be. But when we look at the I guess the industry verticals, as we might call them today, the machine to machine, the Internet of Things, and so on, that's really where we need that scalability. And also that's where the types of applications that we'll see being supported by the network will be extremely diverse. And because of that, things like the throughput, and we've got here also the latency, has to be extremely flexible to support all of those services. Now, as soon as we start mentioning things like latency or throughput and such like, then of course we're talking about quality of service. So we've got to build a highly dynamic, flexible, and scalable network that can also recognize the different kinds of services that run through the network, and apply the required quality of service of those. And on top of that, of course, you've got the billing and the business management sitting behind as well. So, but we'll have a look at shall we say, the proposed network architectures that are that will support that that function. Energy efficiency. Well, the electric bill for a mobile network is pretty high, so of course anything we can do to reduce that is a good business thing to do. Energy efficiency, as far as the mobile is concerned, it really comes back down to battery life. So when we say mobile here, we're talking about all of the different kinds of devices that will be connected to the network. I mean, there'll be very specialist, low energy consumption type devices, those that you might see more in a machine to machine type application, as well as the portable and mobile equipment that we would be using as smartphones and tablets and so on. So new technology that we're inventing here should have a very close eye on the amount of the power consumption for these kind of devices. The applications, the software developers, the hardware and the chipset developers all have to keep an eye on energy consumption. And part of that, I suppose, is from a network operating perspective, is cost efficiency. So sure, we want to build these networks that are fantastically clever, but we don't want them to be too expensive to run. And in scaling the network, in increasing the capacity of the network to support tens of billions of devices, and of course to support many different kinds of applications, we've got to keep an eye on the cost. It's got to make business sense at the end of the day whenever we're building those networks, because if there's too much expense in there, I mean, there's a little sort of side note here that says, if we can control capacity, if we can control capex and opex, then there's an encouragement there to invest and to expand the network. Whereas an expensive network to run, very difficult to justify additional investment. We mentioned flexibility. The network is likely to be fairly rapidly evolving, and of course a heterogeneous system. There'll be lots of different systems and subsystems and different radio access technologies and devices, all part of the network. And of course our 5G system must be able to handle all of that in a more or less seamless fashion. There's a long list. We'll kind of go through this in a moment or two, but there's a long list of services that we might expect to be supported by 5G systems. So it says in non-traditional services, I mean, HD mobile, well, I suppose, we're kind of maybe doing that at the moment. But of course, there's all the machine-to-machine, the cloud, and there's clearly some sort of fairly precise challenges with each of the new types of services that we might expect. And we mentioned before, spectrum. Get more spectrum, use it more efficiently. That, I suppose, is the mandate of any spectrum utilization. So as far as standards are concerned, I mean, clearly the ITU is sort of the main party involved here, at least for the time being. So the ITU, there's a working party here, working party 5D. These are the guys that are kind of working on the problem at the moment, and they've already released a few different papers, one of which I recommend is this sort of future trends of terrestrial IMT systems. So that's that 2320 is a reasonable document to read. Completed at the end of last year, so there's some pretty current and relevant information in there. Now that brings us up to sort of, we're part the way through the year here. So there's a lot of exciting stuff going to happen next year, and I guess one of the key things is this WRC 15, and we mentioned we need more spectrum. Okay, so the ITU running this, the World Radio Congress, they're going to have to start the process of, on a global platform, investigating and finding available spectrum to give the operators, or to at least have resources for the operators to deploy these high capacity networks. But we'll mention that in a bit more detail towards the end. But technical performance requirements and evaluation criteria and so on, all of this running up to sort of the middle of 2017. And then proposals from various bodies like 3GPP and others will be submitted to the ITU. And then, we can start to, it says here, consensus building, so making decisions on the candidate technologies, and then of course there has to be specification after that. I mean, how that compares with 3GPP? Well, okay, 3GPP perhaps are not, they're not specifying what the performance. 3GPP are not telling us what 5G should look like. Really, that has to come from ITU. So ITU will define the performance criteria of a so-called 5G network, and then 3GPP and others. There's a lot of different partners involved in this. Other standards bodies, of course, vendors, operators, application developers. They will come together and write specifications, technical documents that tell us how do we meet the requirements of the ITU recommended system. So we're expecting that some specifications to sort of be firmed up and frozen, probably sort of late 2018 into 2019, ready for deployment in 2020. I mean, at least this is the current timescale that we're looking for. Just another note here as well, that the IMT 2020 seems to be the name that we're giving to this sort of next generation technology. We may already be referring to it as 5G, which seems like a reasonable increment in terms of network generations. But it's not. It's quite a nice little phrase, that IMT 2020, because I'm sure some of you will remember IMT 2000, which was really the definition of 3G, and then of course we had IMT Advanced, which is really the result of that was LTE Advanced, and now we have IMT 2020, which is proper full-blown 5G. So yeah, two bodies to really I guess to look at if you're interested in doing more reading on this is, well, clearly the ITUR is a place that you should go to find out more, but also the NGMN, the Next Generation Mobile Network guys, they've released quite a lot of different papers related to this topic as well, and you'll see quite a lot more. My source material is coming directly from NGMN, but they've got a very nice approach to defining what they think future generation systems should look like, and how do we define the services and so on. Now, I can see one or two of you raising your hand, and presumably you have some questions. We'll deal with questions right at the end, so I'm going to drag that chat box back in at some point, and we'll be able to deal with a few questions and so on. So hang on to those questions until we get to the end. Right, so here is something from the NGMN, Next Generation Mobile Network. What they've done, I think, which is quite nice, is to define, as they call them, use cases. So they've got these... They've got 8 different sort of criteria, should we say, or 8 different categories of service. For example, high density broadband access, broadband everywhere, extreme real-time connectivity, and so on. So these are their sort of service categories, and then what they'll do as a subcategory, they give example services of what we might mean. So, for example, in high density broadband access, what they refer to as pervasive video, smart office, communication service provider, cloud, or crowded media, which is sort of sports events and stadiums and so on. And they define what the requirements of those individual services might be, and from that we're able to extrapolate what the performance requirements of the network should be, perhaps in terms of the quality of service attributes of those connections. So high user mobility, so high speed trains, moving hotspots. And interesting, what they refer to as 3D connectivity, which really means commercial aircraft. So instead of thinking very much on a sort of two-dimensional plane, providing services on the ground, we can extend that into the third dimension and start providing connectivity above the ground as well. Maybe to a certain extent we're already doing that, when we're providing services in high-rise office buildings and so on. But really, we're taking it, to the next level, almost literally there. Yeah, ultra reliable communication. So things like autonomous vehicles, you can imagine sort of automated robotic systems in healthcare would require extremely reliable communications. And this is when we can start thinking about remote control, remote control type systems that will have to have very low latency, very, very high reliability, and so on. Broadband everywhere, 50 megabits per second everywhere. I'm going to show you a list of full KPIs for both the user experience and for the system a bit later on, and you'll see you'll see just what those requirements are, and it's impressively high, shall we say. But yeah, low cost networks as well, because we mentioned the capex opex metric in terms of what the motivations might be for moving towards 5G. So it's about improving performance, but it's also about managing the cost of building these networks as well. Internet of Things, smart wearables, sensor-based networks, mobile video surveillance, example services for those, and there's a whole bunch of sort of broadcast-like services, as they say. So, and have these categories of local, regional, and national. So by local, what we mean is that it may be possible to broadcast from a single radio cell or from a single definable region. Yeah, and they're talking about kind of news and local content, local interest pieces and so on that can be broadcast in a very, very small area. Of course, regional and national. Then, of course, the context of the information that you're broadcasting can grow according to the region which you find yourself. Tactile internet, bit of an odd phrase, that one, but I think somebody wrote in the left-hand window at the bottom there, your virtual and augmented reality. So the idea of it's the Google Glass idea. It's the Microsoft sort of hollow lens, and so it's this ability to wear some head-mounted gear, and which your environment is then enhanced in some particular way. But to do that successfully and to make it useful, of course, you're going to need very high-speed communications to do that. If we're going to be overlaying video streams and information tickers and so on your environment, then we do require very low delay, high-speed connections for that. Also, part of that sort of tactile internet thing as well is this ability of wearing again the heads-up display kind of thing. Maybe you're a surgeon performing surgery, and we can have information displayed, directly into the surgeon's location. So there's lots of interesting services in relation to that, and also lifeline, public safety, natural disaster type communications, and so on. So I mean, this is that's just a snapshot really of what NGMN are defining in terms of what services might we be using in this sort of 5th generation network. So these use cases, I mean, there will be countless of them, but what that enables us to say is to say, okay, some or all of these will be sort of very delay sensitive, or will require certain latency requirements. There's high-speed internet, mobility on demand for IoT connected objects, that kind of thing. Best effort and what the reliability factors. So I think that why it's a useful thing to do, to think about lists of services and these so-called use cases really, is just that it says down at the bottom here, to ensure that the level of flexibility required by 5G is well captured. So if we understood what it's going to be used for in various contexts, then we can define much better how we manage the processes and the communication attributes of the network. So it may seem a little bit sort of fancy or ephemeral, shall we say, to define these future services, even though we're just guessing, I guess, to a certain extent. But it is important to do that so we know how to build the network for these various use cases. So when we think of the business models, when we think of sort of today's business models, I suppose there is the consumer, sort of business to consumer business model, there is the business to business consumer model, and I think more recently we might call like B2B to C model, or business to business to consumer model, which brings in things like the industry verticals and the machine to machine. But we have to think on a slightly different plane when it comes to 5G. So we certainly the first two that you see here, asset provider, connectivity provider. I mean, these might be traditionally your mobile operator. The people with the base stations and the radio licenses and all the transmission networks and so on. But as the provider of well, let's do connectivity first, because that's sort of like the common one, shall we say. And certainly is an extension of the existing business models that we have. So basic connectivity, provide best effort IP communication services either directly to your consumers or into businesses, and then those businesses will decide what to use that connectivity for. So wholesale MVNO is a typical service for that, and that's of course what we see today. We've seen for a number of years. But I think as we move forward, this, as it says here, enhanced connectivity. It's no longer just basic best effort IP connectivity, but all of the metrics or attributes associated with the IP connectivity can be managed according to some quality of service or the billing factors and so on. All of those can be controlled, maybe by the provider of connectivity, or maybe by the third party, which is an interesting idea, that the third party can define the delivery metrics for the operator, and more or less control how the operator provides the service directly to their customers. And I'll show you a diagram in a moment or two, which more or less shows you that concept. So of course, connectivity is the main thing I would suggest in any communication services. That's kind of what we're all about. But when we think of the operator being as the asset provider, well, I suppose we're into the world of cloud type services there. So you see the usual cloud definitions here of infrastructure as a service, network or platforms as a service, or XaaS is just, well, anything as a service, really. I mean, that's more or less what it means. So given the increasing asset capability of an operator, it makes sense that perhaps what we should start to do is to leverage that cloud-like capability as a business model. Why shouldn't we be talking to smaller or larger third parties about using that infrastructure to host services, to provide services to the customers of that third party, and as well network sharing. The ability to share network infrastructure between, it could be multiple operators, it could be multiple third parties, and so on. And again, something that we talk about quite a lot even today, this idea of sort of radio access network sharing, or sharing transmission resources and so on. But perhaps we're doing it in a very sort of static way these days, where we negotiate an SLA, we sign a contract, and so on. But we're saying here, you'll see it says operators based on static or dynamic policies. So think about congestion or traffic profiles, or billing profiles, and that network sharing capability can be sort of dynamically adjusted according to the types of customers or devices or services that are running through the network at any given time. So already we're getting a feel now for the increased flexibility of the system, and the idea that the system can sort of self-manage its resources according to the requirements of multiple connected parties. And then the one that, certainly I've spent quite a bit of time talking about this over the last 24 months or so, but yeah, partner service provider, we talk about the OTTs and WhatsApp and so on in there, but it's pretty obvious, I think, today to both the operators, the connectivity providers, and of course those third parties, that the two together are probably have a greater total than the individuals. If not putting that very well, but okay. Operators understand that they have to make partnerships these days, because people will go to WhatsApp, people will go to Facebook and Skype and so on, regardless. So the idea that the operator can make some commercial arrangement with nominated partners is not necessarily a new idea, but of course the capability of the network perhaps is a little bit restricted at the moment, and the idea of a 5G network gives you sort of ultimate flexibility both to the operator and to the partner. So I guess the first one that you see here, operator offer enriched by partner, maybe that's something which is very much like today's offering, and that will be extended as we go through your 4G systems like LTE. But perhaps a slightly newer idea, although there are one or two sort of current examples like this, with a partner offer enriched by the operator. So you've got third parties selling particular products. I mean, these could be sort of the should we say domestic electronic type products. So we're talking microwaves, washing machines, digital cameras, vehicles, and so on. And the idea that that the seller of that product or service can enhance their product by some arrangement with a communication service provider. So when you buy your next vehicle, it will come with internet connected capabilities. Then clearly that vehicle company needs to have partnerships with the communication service provider. So this is what we mean by, I mentioned before, this kind of this idea of B2B to C, business to business to consumer, which has more relevance for those industry verticals like healthcare or automotive, the vehicle companies, as well as sort of the embedded electronics devices, the consumer electronics sectors as well. So there are plenty of business models in there, but the increased flexibility that we need in the network. Okay, we may be talking about complexity here as well, and how do we manage the complexity of the network to keep it flexible and dynamic, but without overcomplicating and over expensing the system. Something else that when you read the ITU documents and the NGMN documents, as well as other documents, I think I've got a few references in here to a good document from South Korea Telecom as well, SKT, and there's a lot of talking about value creation, which kind of brings it back into the I guess the area of service as well. So 5G will bring multiple propositions to all customers, but the definition of the customer in this case is not limited to just general consumers and enterprises. It's much more about the verticals and other partnerships. So we talked about there being sort of tens of billions of connected things. Clearly they will not be directly connected with human beings and smartphones. At some point we'll probably reach global saturation of smartphones when there are about 9 billion or 10 billion or so connected smartphones, tablets, and so on. And the rest of it, the other sort of 40 billion, have to be machines and vehicles and sensor networks and cameras and so on in there. So the definition of what is a customer maybe has to change. So if we are an operator and we're thinking about future business models, we got to sort of redefine what we think we mean by that customer, and in defining those customers as well, these values which we have to attribute to these different classes of customer. And there's a very long list of words there, available anywhere, anytime, delivered with consistent experience, and so on and so on. Trust and reliable communications, highly resilient network. I mean, we could probably attribute those values even today's networks. At least in the design and building of a network, we would have as our target to meet those particular values. But to do this in a way which is scalable and which is cost effective, perhaps given today's technologies and the way that we think about building radio access networks and connecting them to a routed network, and we manage the sessions and the mobility and so on. And perhaps building a network that can scale to 10 billion connected devices and still meet all of these values. This is going to be a bit more challenging with today's rather more sort of rigid or static approach to thinking about and building networks. So just to give you an idea of what we're talking about in terms of performance and user experience KPIs. Now, the user experience data rate. Now, these numbers here, I mean, I had to do a bit of a double take when I looked at this table. But normally when we see a table like this, we're talking about, this is the bit rate available to the radio cell. Okay, so that rate will be shared between multiple users and so on. But actually, once you start reading around the subject here, these numbers. So, for example, broadband access in dense areas in the downlink direction, capability of 300 megabits per second. Now that's per user. Okay, which is pretty astonishing, really. So we're looking at 300 megabits per second with an end-to-end latency of 10 milliseconds, with 0 to 100 kilometers an hour of mobility. So 300 megabits per second per user in this, so-called dense area, and we'll show you a classification of that in a moment, and 50 megabits per second in the uplink. Indoor high ultra broadband access, so second row in this table. Again, the document goes on to talk about being able to deliver a gigabit per second service to tens of users within an office space. So think of a typical office. I mean, I don't know, just look up from your computer at the moment, and perhaps you can see the office. So we're talking about maybe 10 to 20 people in that office being able to experience a gigabit per second in the downlink and 500 megabits per second in the uplink. Now, if this is per user, and we're talking then about delivering this to multiple users within an environment, clearly the actual radio cell or radio access network capacity is going to have to be tens or hundreds of gigabits per second to be able to manage those very, very high requirements. And you can see, I mean, that's more or less the case for all of the. I mean, I'll let you read the table later on. I'll let you download this presentation actually a bit later, so you can actually spend a bit more time looking at this. But then when you look at some types of services, so this might be sort of mission critical, public safety applications, ultra low latency, so 50 megabits per second with a 1 millisecond latency. Which is pretty astonishing. When you think about today's networks, we're probably looking at maybe 30, 40, 50 millisecond is pretty good for today. So 1 millisecond latency is a very challenging thing to do if you've got to build an end-to-end based network with all of the various transmission networks and scheduling functions and routers and switches and so on. Millisecond delay is quite a challenge. Shall we say. So I mean, that's the user experience, but when we sort of extrapolate that then to system performance, and we have the same use case categories here, so broadband access in a dense area, then we're looking at connection density here. So yeah, this is number of users per square kilometre. So 200 to 2,500 users per square kilometre. And the traffic density means in that area, in a single square kilometre, that's what these numbers mean, we have to deliver a service of 750 gigabits per second. Okay, now that's a lot. But if you look at the next one, the indoor one, which is this, delivering gigabit per second to multiple users within a sort of an indoor office space, we're looking at maybe 75 people per 1,000 meters squared, and delivering a sort of combined capacity of something like 15 terabits per second per square kilometer. And again, these are just huge numbers. So you can understand then why we need more spectrum. I mean, if you are working for an operator and you have an idea of how much spectrum you currently own and what the current performance of your LTE or LTE advanced network is, I mean, these numbers are sort of 10 to hundreds of times more than what the current network can actually provide. And also the numbers we're talking about, I mean, I don't know, like if you're in an office and we're talking about a gigabit per second, okay, I mean, what is it that you are doing? What computer, what application are you running where you need a gigabit per second? I mean, I don't know what that is at the moment, but I'm sure that slightly more creative people than me out there writing applications and such, like, they've got a very good idea what you would utilize a gigabit per second capacity for. But we have to wait and see what those people come up with, and we've got 5 to 10 years to figure out what services will use that. Also things like your broadband access in a crowd. Okay, so very, very high density, 300,000 people in a typical stadium, for example, and all those people in that stadium are watching. Well, they're there to watch the live event, of course, the football game or whatever it is, but they also want to be able to see different camera angles and look at the slow motion, high definition replays and so on. And you're going to have 30,000 people in there, so clearly that's another high demand kind of area. So. So the should we say the throughput requirement, when we extrapolate these different kinds of use cases or services, it just points to a very, very high capacity system requirement, which I suppose is absolutely expected. Now the current technology, so we're sort of maybe release 12, perhaps the networks on the ground at the moment aren't really 3GPP release 12, but we're getting there very quickly. So that's basically LTE advanced. So this column here, you can basically say, okay, LTE advanced. So 100 megabit per second on average, so peaks of 600 or so for category 11 or 12 devices. So we're looking at sort of 10 to 100 times increase required over today's networks. End-to-end latency, a 10 times improvement in that. So 10 millisecond down to about 1 millisecond where required. Has to be improved. Mobility in terms of actual speed across the ground, we're looking at 350 to 500 kilometers an hour at the moment, high-speed trains and so on. But this 5th generation system, we should be able to go at least a 50% faster than that. So we're looking up to say 750 kilometers an hour or so, and still support those services. Yep, spectral efficiency. Well, it's a bit vague, this column, because we've got spectral efficiencies at the moment, with LTE and LTE Advanced pushing about 6.1 bits per second per hertz, and there are other ways of measuring that, of course. But it just says here, improvement needed. Well, push the envelope for a substantial increase. Now, how we do that is very much dependent on what choices are made for the radio access technologies, and I'll give you a quick list of what those might be a bit later on. Connection density, 100 times more. So however many people use service per square kilometer, 100 times more than that for fifth generation networks. So very challenging, very challenging. So we've more or less said that today's networks don't really have the capability to offer those kind of services, which is fair enough, because today's network was probably was specified on a slightly lower set of requirements than this 5G system. So whatever it is we're going to do in 2020. So when we think of when we consider the network capabilities, how do we improve the network capabilities? And this is the throughput latency efficiency question. So things that we're doing about it today, clearly we're thinking about small cells. Carrier aggregation is a big thing at the moment, and we're playing around a bit with MIMO, coordinated multi-point as well as another important thing. Sort of cleverer receivers to manage interference and so on. So we are doing some things today which addresses some of those issues, but they need to be carried on. They need to be taken to a next level, really, for 5G systems. But there's also consideration for it says enables for operational sustainability. So when you think about how do you optimize the network, how do you fix problems in the network, and how do you add capacity and make the system flexible enough to accept new services with new quality of service requirements and so on. I mean, how do we do that at the moment? What are the processes involved in doing that? How many people need to be involved? How automated are those processes and so on? Then there is some suggestion that, again, today's networks, even though they might seem quite sort of advanced and complicated, how do we further optimize and further automate those processes, as it says, for operational sustainability? Make the network as automatic as possible, and to a certain extent give up control of certain aspects of the network to the third parties and let them worry about how they want their service to be delivered. And in a sense, that's very much like business agility as well. So when you look at the different differences between service requirements for, let's say, vehicular communications and access versus a CCTV system or a public safety system and so on, how quickly can we sort of reinvent or reconfigure the network and network services to expose to ourselves a new business segment? And again, the big sort of subjects, shall we say, our big topics, of course, self-organized networks, network function, virtualization, software-defined networks, fixed mobile convergence. I mean, these are topics that we've talked about for some time, or I'm sure you've talked about them for some time. But this is a large-scale adoption and standardization of those topics, and I'll show you in a moment how those might fit into a 5G network. I mean, there's other issues perhaps that are not directly addressed by this list, but, such as security and managing the building processes and so on. Those are sort of other elements that need to be thought of. So, according to NGMN, they have some, should we say, general design principles for the radio, for the network, and for the management stuff that happens behind the scenes. So clearly, more spectrum, leverage spectrum, cost-effective, dense deployments. A lot of the capacity that we require will have to be achieved through very high density networks. So densification of the radio cell. So radio cells will become, instead of thinking about them in terms of hundreds of meters or kilometers, we're thinking about them in terms of tens of meters. Every space inside of a building will have its own radio cell and such like. But one of the problems of doing that clearly is going to be very, very high interference. So how do we manage that? So coordination and cancellation of interference, and there's a lot of work going already within the LTE advanced techniques and mechanisms to look at both frequency domain, time domain, and other techniques that we can use to manage the interference of the network. Dynamic radio topology, so moving cells and so on. And then in the network, I mean, the first statement here, it says create common composable core. So minimize the number of entities and functionalities. An important entity here, where it says CU functional split, control plane, user plane functional split. Very lean protocol stack, not too much overhead in the network. Keep the delivery process as simple as possible. No mandatory user plane functions that we might see as far as today's networks are concerned. Minimize legacy interworking. So sadly all the circuit switching, MSC stuff and so on. Try and minimize our interaction with that side, because it represents at the moment at least quite a big cost. I mean, if you look at what you're doing in terms of VoLTE or circuit switching fallback at the moment, really what we're doing is, we have to support the existing system, and that's going to be a financial drain on the system. So whatever we can do, to minimize the legacy system. We'll see in other documents that backwards compatibility is the thing that we should be concerned about as well. So perhaps they fight a little bit over that metric. Radio access technology agnostic core, of course, fixed and mobile convergence, something we've been talking about for a while. And then the stuff that happens in the background, so all this stuff, operations and management, when we talk about operational sustainability and business agility, that's kind of all going on in the background. So your automation, self-healing, probeless monitoring as well, so we minimize the number of sort of third-party equipments that we need to put into the network to monitor performance. And with probeless monitoring of the system performance as well, we can give that information up to the sort of self-organizing, self-optimizing features, and have real-time reporting what's the word? So real-time reporting and reconfiguration of the network to maintain efficiency throughout the system. So, I mean, they are just bullet points in the end, but of course, what NGMN are trying to do is to set out some sort of groundwork on which the specifications can then be grown. So there's a few more bullet points there that I won't bore you with. Nicer picture here. Again from the NGMN, and this is a sort of a conceptual idea of what that network should look like, and it's split into three very distinct phases. Now, again, looking at this, you probably recognize some of the characteristics of today's networks, but the idea is that this sort of bottom layer here, this sort of blue layer that you see in the bottom, infrastructure and resources layer, this is really where things like the NFV, the network function virtualization, really plays the biggest part in here, because we're hoping to use, shall we say, standardized sort of computing type platforms, and we'd like to have them as dynamically configurable as possible, given the number of different types of services and service attributes that are required. So okay, so today even we're doing NFV. We are virtualizing the network function. So we get a standard server, we put on there an MME function and a serving gateway and a packet gateway function, and maybe the billing and PCRF and so on. So we can do that today, but really all we're doing is we're sort of outsourcing that function, shall we say, to a standard computing platform. But how flexible is that computing platform? Okay, can I move those functions to a different location or onto a different platform if the current network traffic profiles dictate that we need to push that to a higher performance server, or we've got some a third party that wants to do some specialized service and we don't want to hang up that particular server for that third party. So how dynamically can we move those functions around within the system? I mean, that's really what the 5G bottom layer of the network really is all about. Is sure, having a whole bunch of, should we say, standardized computing platforms, but the flexibility to define and to move the functions to reconfigure the network according to particular traffic profiles. That's quite an important aspect of it. And clearly, in that part of the network, what's being done? Okay, why are we reconfiguring? How are we reconfiguring? What are the parameters of this reconfiguration? Then clearly that has to come from some other layer here. So the business enablement layer here, of course, separates the communication services, which is the connectivity layer below, from the actual, should we say, the traffic plane itself. So, I mean, sitting right at the top, the business application layer, you can see in there operator services, enterprises, verticals, third parties, and so on. So they will access the network services via some form of API. Okay, and then according to the different types of services that would be pushed through the network, should we say, there's a library of modular network functions. So if I'm communicating with a vehicle, or if I'm communicating with a sort of CCTV system or a network of sensors, what are the standard configuration parameters for the network if I need to read 1 million sensors from from an industrial plant, for example? Well, we're saying we should be able to standardize that. There should be sort of a library that we can refer to, and then push that information into the network to connect the services according to their QS capabilities and so on. And part of this as well is well, the 5G devices. I mean, remember, these are not just smartphones anymore. They're pretty much anything electronic, I suppose. We could more or less say. So part of this configuration of the system is not just about how and where do I move the packet of information, and how do I configure this switch and that router and that mobility management control function. Sure, that's part of it, but also the devices themselves become a configurable entity within the network. As well as all of the radio access technologies in here. So this is this middle layer here, and I think as well you can see the end-to-end management and service orchestration here. These are really absolutely crucial layers to enable the efficiencies and the flexibility of the network. So I think orchestration, I mean, it's been a key word maybe for a number of years, depending on what field you work in. But I think orchestration of many thousands of devices, services, and functions now is really going to be absolutely key. And part of this concept is to say, okay, well, now I've got she would say, almost like a blank slate. I've got a really clever traffic-based network, distribution system sitting at the bottom. I've got techniques to configure and control that network, and I've defined how my customers might even access the system. So NGMN, they talk about this idea of a network slice, okay, which is a bit of an odd phrase, but a slice really is, it says here, contains all the network functionality to render a specific use case or service. Okay, so when you're thinking about basic smartphone, okay, 5G slice 1 smartphone. Okay, so we know how to configure the smartphones, we know what the requirements might be here in the radio access network, and we know what control plane and user plane entities are required in the network to service those smartphones. But then when you look at a completely different kind of service, like autonomous driving, for example, okay, so the Google self-driving car, well, clearly the self-driving car in its own right is a device within the network, but the core network requirements in terms of control plane, user plane, and how they access sort of the verticals in the third party, they may be completely different to the way the network has to be configured for smartphones. So we have these. I mean, I guess a slice in a way is just a service-based profile, okay, and we can make use of these libraries to configure all the network components within that base layer to ensure that we get the delivery experience, the delivery attribute that's being required. And you can define whatever slices you want, and of course those slices will run simultaneously in the network. And there may even be an idea here where, I mean, you would sort of expect it would be the operator, the asset provider, the communication provider, that would configure the slice. So they would write the rules, they would create the library context for each of these particular slices. But there is a thought that maybe through the right kind of API, you could actually let the OTT, the third party, to define the slice. Now, clearly, there would need to be some good working relationship, should we say, between the third party and the operator to do this. But where we think of things like network sharing, if the business model is primarily connectivity provision and not service provision, then of course you would want the third party to think about the service attributes, and then you just become the configurable connectivity provider. And that's a potential business model, I suppose. So 5G slice is part of that. And we've mentioned already things like NFV, already an important thing, I think, in today's networks. Being adopted by a few mobile operators at the moment, but it's going to be certainly within LTE Advanced, over the next 5 years, we're going to see in our core networks, in our kind of traditional mobile core network, we're going to see more and more virtualization of these services taking place. Maybe we'll do it at the back end first. We might think of a billing system or a customer relationship management or customer experience management system being sort of virtualized to different systems. But that's going to creep more and more into the core of the network. So it's not completely out the ordinary to think that we might virtualize the function of something like the MME in an LTE network or the PCRF perhaps. But it's more than just virtualizing the function, it's configurability and flexibility as well, which is really the 5G process. It extends, this virtualization concept extends all the way out to the radio access network. So these so-called sort of radio units, digital units, the baseband processing functions of the base station, which are the things that perform modulation, demodulation, error coding and management and so on. All of these things happen at the moment inside of the base station electronics, which is, it's kind of a useful thing to do to distribute that type of functioning. But there is this idea that what we should be doing is sort of centralized processing of that information. So we just got a remote radio unit sitting out here, which is really just a clever antenna in a way. And what we do is digitize the stuff that we see on the radio interface, and we send it down a very, very quick interface back into the core network. And all of the processing can be done effectively as a base station in the cloud. Now that interface that you see, this sort of interface that's you see here, is often being referred to now as the front haul. We might be familiar with the term backhaul, which is how do you connect the base station to the rest of the network. Now, because of the very, very fast data requirement of this type of architecture, we refer to it as front haul, and front haul will have to be fiber optic, high speed, low delay delivery systems. And sitting in amongst all that as well, we have SDN, software defined network, because down there in that base layer, you're going to have a lot of transmission capability, shall we say. And in our sort of typical networks, it's normally that we'd have, shall we say, local instructions on a switch or a router which understand what the network looks like and how do we best move the information around. But those instructions are often held on a local basis, so each router has its own view of the network, shall we say. And but the idea of SDN is that we can centralize the view of the network, and that gives us much better efficiency control over the transmission capabilities of the network. And that's just another one of those flexibility issues. But I mean, SDN and NFV are not, of course, they're not new things, but we are going to see large-scale adoption of these functions as a standardized technology. And if you're working in and around that area at the moment, you'll know that there are several different flavors of standards for NFV and SDN, but there's a push to get all the vendors, all of the protocol stack developers and so on, to converge on a single standard way of performing those functions. And when we come to the radio access, there's a long list of should we say, things, features, functions that we would expect that will improve the performance of the network. So a lot of these have yet to be decided exactly how they will be done. The technical specifications are nowhere close on this basis. But things like device to device, first of all, I suppose content-centric network, where we can actually place the content as close to the mobile as possible, perhaps even at the remote radio unit here, and then each mobile in the system is able to communicate directly with its neighbors, and that's a fantastic way of optimizing the delivery path. We can also adapt and optimize the content according to the delivery path performances. So multi-link network, discovery services, proximity services, is really just a way of optimizing the delivery processes for content. Now, something that's being referred to as elastic cell. Now, this looks very much like coordinated multipoint that we see as part of LTE Advanced. But the idea that a mobile is not as in the bottom case here, so this where you see this UE, this is a cell-centric case. I mean, that's kind of how our networks work today, where a mobile is associated with a single base station or a single control element in the network. But the idea of a connection becoming user-centric, it doesn't really matter where it gets its service from. We could be served by multiple base stations at the same time, and this is very much like coordinated multipoint from LTE Advanced. But this has to work perhaps with a heterogeneous approach as well. So we're not suggesting that all of these base stations are the same base station, or even the same technology. So an LTE site, a Wi-Fi site, a something else site, and they can collaborate in the delivery of services to that user. But to make that work, really good coordination is required. Synchronization to avoid interference, and we need very good reporting as well. So the reporting structures and mechanisms, something which is being defined within LTE Advanced, that'll have to be kind of again taken to the next level for 5G services. Ultra dense small cell, just an extension of small cells, really. We mentioned before that every room in a building would be its own cell, perhaps managing its own interference and coordinating resources as people move from room to room. And something interesting which is sort of enabled by sort of the millimetric band. We'll say a bit more about spectrum in just a second or two, but it's likely that we'll be using much higher frequencies because that's where the capacity is, that's where the space is really. So the wavelength gets very short, and that enables the use of much cleverer antenna techniques. So this idea of horizontal and vertical, beam control, massive MIMO, 3D beamforming is really what they're referring to it, in that we can service multiple users and track them across the radio cells, or track them within a room, perform beam switching and so on, as they move around. Something which is suggested for LTE, and we still support an LTE Advanced, but rather difficult to do this in an efficient way, given the current frequency bands that we use. But as we move up the frequency spectrum, this becomes a bit more of an easier thing to do, I suppose we could say. And the non-orthogonal multiple access. We've sort of come from a CDMA system where we're sharing, sort of the power domain in a sense, to OFDMA where we're sharing the time and the frequency domain. But now with non-orthogonal multiple access, the suggestion is here. If you look at this, I know it's a very small picture here. Okay, but if you look at that sort of red and yellow section there, what that seems to be suggesting is that we'll be allocating resources to multiple users on the same frequency and at the same time. But what we're able to do, like we might do in CDMA systems, is to sort of to share the available power between multiple users, and this is so-called non-orthogonal multiple access. But of course, interference becomes a big issue here. So there's a technique called successive interference cancellation, which will be part of this system. And there's a couple of other things I've just thrown in here because these are just under consideration. But universal filtered multi-carrier is a possible radio interface technique, or filtered multi-bank, or filtered bank multi-carrier. It's still under consideration. So we may or may not see those in the future. But we've got at least 4 years before we start seeing any kind of serious technical specification about how these new radio access techniques are going to work. Undoubtedly, there was some sort of new multiple access type of system in here, combined with new antenna techniques. The sort of the massive MIMO, as they're calling it, the beamforming and so on. These are things which lead to very good efficiencies. as well as yeah, hybrid duplex or full duplex communications, because even today we're still using proper frequency or time duplex type systems. And the idea here is that it doesn't matter what frequency band you're in. Okay, so in FDD systems, of course, what we do is we have we specify an uplink band and we specify a downlink band. And in the TDD cases, we have very specific intervals where the base station will transmit or the mobile will transmit. In the case of this interband frequency duplex or full duplex, well, it doesn't matter. Anybody can transmit at any time, anywhere within the frequency band. Which is a very good, efficient thing to do, but it does make your radio transmitters and receivers rather complicated to build, especially when you combine things like when you start thinking about carrier aggregation that we have at the moment for LTE Advanced. Given the diversity of frequency bands over which this technique might have to be adopted, it places the difficulty, the complexity, really right back into the into the court of the chipset and the RF chipset providers. But an interesting technique nevertheless. So the final thing, we are right on the hour here, but we've got another 5 minutes to go, if you just bear with me. Right, spectrum for 5G. Well, I kind of hinted at the beginning of this presentation that we need a ton of it. We need lots and lots of spectrum. So another document I recommend that you read. This is the 2290 document, further future spectrum requirements. So in the most extreme cases, there's nearly 2 gigahertz of 2 gigahertz of spectrum in total will be required to meet the projections done by the ITU. Okay, now this is in the most extreme case, so it's a good headline figure, isn't it? 2 gigahertz of spectrum required for 5G systems. Now, quite a lot of that is already assigned and is in use. So think of the 900, the 1800, the 2100, the 2600, and so all of these bands that are currently in use for GSM, UMTS, and LTE. It's already been defined as IMT spectrum, and of course could and would be used for IMT 2020 services. But it very much depends on the modelling that's been done by the ITU. Now, okay, go and read this document, the 2290. It describes the entire modelling process. Clearly, it depends on geography, on the market availability, the types of services, and so on that we expect. But not all of this spectrum is actually available. How much spectrum that needs to be found depends on the country. So in some cases we need to find 500 megahertz of additional spectrum. In other cases we need to find 250 megahertz of spectrum. It just depends what the local regulators have been doing. Now we're going to know a lot more about this at the end of the year. So of course there is the WRC 15 is coming up. So those spectrum people will get together and we'll know more about this towards the end of the year. But there's quite a lot of proposals and a lot of candidate bands, should we say, being proposed. So current proposals, okay, in the 1400 band, the 1900 band, 2100, okay, and a little bit higher. Now the two that seem the most possible, that's sort of in and around the 1500 megahertz band and the 3.6 to 4.2 gigahertz band. When you look at this on a kind of a global basis and look at the countries and the companies that are proposing bands, then it looks like this sort of 1.4 band and the 3.6 band are strong candidates for next generation services beyond WRC 15. Now I mentioned things like the smart beamforming, the massive MIMO, and so on. We benefit from much smaller wavelengths in terms of building and managing those types of bits of hardware and software. So there are frequencies or bands above 6 gigahertz which are also being considered, but maybe not seriously until WRC 18. Okay, and the candidate bands in that case are sort of around about 13, 18 gigahertz, 24 gigahertz, 30 gigahertz and beyond. I mean, you'll see up here, we're up into the much higher frequency bands. Depends on the country, depends on the operators and so on, and making these proposals. But yeah, I mean, the one thing that's absolutely certain in all of this is that if we're to meet those sort of multiple 100 gigabit or terabit per second per square kilometer services, we need more spectrum. Despite all of the fancy stuff we can do with antennas and new access, multiple access schemes and so on, spectrum is absolutely our friend when it comes to building high capacity systems. So we've got to find more of it. But even though some of the antenna techniques that we describe are should we say, a little bit easier to do at these higher frequencies, using these higher frequencies as well have some have some downsides. You know, the energy tends to travel in very straight lines. It doesn't diffract, doesn't refract particularly well. So creating good coverage indoors or outdoors with these very, very high frequency bands is going to create its own set of problems which will need to be solved as well. But that's something that will be thought about in the context of defining the specifications. And of course, network planning will have to be a big part of that as well. And that, in an hour and 5 minutes, brings us to the end of the 5G presentation. So I said I would remind you of our contact details if you're interested in anything that you do. We will at some point be creating sort of an official, you know, 5G planning, 5G technologies and business course. So keep an eye on our website and brochures, and we will let you know when we have a sort of a, you know, a 2-day course available, where we'll of course talk in much more detail about those topics we've mentioned today. Now, if you want to see this presentation, I say we've made a recording. Paul Waite will send that link out to you at some point. But also, if you want to view the actual slides that we've used, there is a PDF version of that document on there on the screen at the moment. It says click to download. And now you'll have noticed that I've dragged in the little chat box again. So if you've got any questions or comments, then, you know, we've got about 10 minutes maybe where we can take a few questions, and then we'll call it a day. If you just want to run away from the room, then that's absolutely fine as well. Thanks for your attendance. We appreciate you turning up on these things. And yeah, do make a note of our contact details, and thanks very much for attending. But I'm going to just sit and look at the chat box here and see if we get any good questions. So yeah, thanks Birol, Terry, Nitin, Mohammed, thanks very much indeed.